Hi, this is Kimball Bullington. In this video, we're going to create forecasts for using a 3-period moving average for a couple of different sets of data for some sales and price information. And then we're going to use MAPE, mean absolute percent error, to sort of evaluate the differences in error. In a second video, we'll be graphing this data, but in this first video, we're only going to look at forecasting the data. So here's our data. We have sales and price data over the course of a year, monthly. Well, actually, I guess this is yearly. And we're going to use 3-period moving average. Well, to do that, we're going to first look at sales. And for 3-period moving average, we need 3 periods of historical data before we forecast. So we go to period 4. And on period 4, we look at the 4 periods previously. So equals average. And then we look at B2 to B4, which is years 1 through 3. So that gives us 3 periods. So we get 666.7. I take a quick glance over here. Yes, that looks reasonable. And I copy that down. We can forecast using this technique. We can forecast 1 period in the future. So we have that. Just going to copy it over to the next column. And the reason why we can do that is when we created the data, we've set it up with the same relative position. So this forecast is looking 2 columns across to the left and looking at the previous 3 rows. And so is this one. This is looking at 2 columns to the left and the 3 previous rows for each cell. So because of that, we can just copy it straight over here. Now, so we have forecasts, and they look decent. And we go over here, let's create errors. So in an error term, we're looking at the actual sales as the truth, and we're comparing the forecast with what it really should be, which is the truth. And so that difference is our error. So we have forecast minus actual is our error. So the way I'm going to calculate it is to calculate absolute percent errors, and then calculate the mean of those absolute percent errors. I like this way of calculating. It's not the only way to calculate it, but I like this way of calculating because I can look at the errors, individual errors, this way. So we have equals abs, and I'm actually going to open another parenthesis here, and I have the forecast minus the actual. Close the first parenthesis, divided by the actual, and then I close the whole function, and that's 0.47815, 48%. Yes, that looks reasonable. I copy it on down. I've got a number down here divides by 0, and it's got an exclamation point, which basically says looks like an error. Well, it is, because I don't have any sales to compare this with, so I can't have an error if I don't have the true term to measure it against, and I certainly can't divide by 0. So we subtract that. Now, up here, to get the mean absolute percent error, let's take the equals average of all of this, and that's it. And 0.207, that looks right. But these aren't really in percent. So what I'm going to do is highlight all of this and just click on the percent button up here. Turns them into percent, and let's give me another decimal place. And so that looks good. And the beauty of having everything in the same relative position, I can just copy this across, and I have my numbers, except they don't look right. 20% versus 120%. Is that really likely? And I'll just glance at the numbers. Whoa, 960%. So something's going on. I look back over here. Oh, 20. So when I was typing this in, and this was an actual error, I left it, but on purpose. But this is an error I actually made and didn't catch the first time through until I looked at my percent error. So always look at your numbers to see if they're reasonable, because you may be able to catch an error. You won't always catch errors, but you might be able to catch an error by doing that. So you can't say in this case which forecast do I really choose, because you're forecasting different commodity here, or factors, or variables. One is sales, one is price. And maybe what you can say is that MAPE does a better job of forecasting the price than it does of forecasting the sales. Maybe. If we had like two different types of forecasts, like a 3-period moving average and a 5-period moving average, then we'd be able to compare the mean absolute percent error and say, well, the one with the lower percent error is that's the better forecast to use. But you can't say we're going to use sales instead of price. So that's sort of limited use in my particular example here. So next is graphing this.